Hello dear students, how are you doing? Welcome back to this remote lesson, Ready to Learn, produced by Rwanda Education Board in partnership with UNICEF and Inspire, Educate and Empower Rwanda. To all Senior 6 students, please come on board for this lesson of Geography with Teacher Jen. Today, we are learning the classification of soils and soil formation in the world. And we will focus more on classification of major soil types of the world, distribution of the major types of soils in the world, and processes and factors of soil formation. You can get the lesson from page 174 to 182 of the student book. To start, I want to give you an activity. Use the knowledge you have got from previous years and other sources to identify the major soil types of the world. Alright. As you know, soil is the uppermost layer of the land surface that plants use and depend on for nutrients, water, and physical support. Soils consist of weathered rock mixed with organic material that is derived from decaying plants and animals. There are three major types of soils in the world, namely zonal soil, intrazonal soil, and azonal soil. I repeat, we have three major types of soils in the world, namely zonal soil, intrazonal soil, and azonal soil. Great. Now, I want you to think of the difference between zonal soil, azonal soil, and intrazonal soil. Think of the difference between zonal soil, azonal soil, and intrazonal soil. Well done! Zonal soils are the soils that cover a wide geographic region in the world, and they depend on the major climatic zones, vegetation, and living organisms in areas where the landscape and climate have been stable for a long time. Zonal soils are common on gentle slopes. They are found both in tropical and temperate regions. This kind of soil has the following types. We have tundra soils, podzol, lateritic soils, chernozem, reddish-brown soils, and desert soils. This was about zonal soil. The second type is intrazonal soils. These are soils that mainly develop due to relief of the area and the nature of the parent rock. These soils reflect the dominance of a single local factor such as parent rock or extremes of drainage that prevail over the normal soil-forming factors of climate and living organisms. Intrazonal soils are also divided into three types. We have calcareous soils, which develop on limestone parent rock, haromorphic soils, which contain high levels of soluble salts, example, sodium ions, which render them saline. We also have hydromorphic soils, which have constantly high water content, which tends to suppress aerobic factors in soil formation. Apart from zonal and intrazonal soils, we have the third type of azonal soils. Azonal soils have more recent origin and occur where soil-forming processes have had insufficient time to operate fully. Azonal soils lack well-developed horizons because of immaturity or other factors that have prevented their development, such as excessive soil erosion. Azonal soils are skeletal soils resulting from erosion and deposition. They lack clear soil horizons. They are common in volcanic regions, glaciated regions, and areas brown by winds. These type of soils include dry sand, loess, moraine, and marine soils, alluvial, but also volcanic soils. Thank you. Welcome back from this short break. As we are continuing our lesson, dear students, you should know that climate is an essential agent in soil formation. Now, I want you to think, on which basis are the types of soil distributed in the world? On which basis are the types of soils distributed in the world? Think about it. Good. Climate is an essential factor in the soil formation. Therefore, the world's major soil types are distributed following the world's climatic distribution. This means that we will have tropical soils, temperate soils, soils related to arid climates, and soils in Arctic climates. When we look at tropical soils, these include lateritic soils, red soils, black soils, and desert soils. Lateritic soils are reddish-brown soils that are developed under humid tropical forest vegetation. These soils have granular dark reddish-brown surfaces underlain by reddish friable clay B horizons. This type of soils is found in regions with heavy rainfall where leaching is dominant throughout the year. The second subtype of tropical soils are red soils. These are soils that develop in a warm, temperate, moist climate under mixed forests. They have thick organic mineral layers overlying a yellowish-brown leached layer resting on a red horizon. They are found in tropical areas where leaching takes place due to heavy rainfall. In tropical soils, apart from lateritic and red soils, we also have black soils. These are found in humid tropical regions where the basalt rocks are common. We also have desert soils. These are soils that develop under sparse shrub vegetation in warm to cool arid climates. They have a light-colored surface soil, usually underlain by calcareous material and hard pan layer. They are found in both arid and semi-arid regions. They are usually sandy and salty. The second type of soils depending on climate is temperate soils. These include podzol, which are rich soils usually found in cool temperate regions. They also include Chernozems, also called black earth, found in extensive temperate grasslands and contain a lot of humus. They also contain brown earth. Brown earth are soils that are found in temperate, deciduous forested areas. Apart from tropical and temperate soils, we also have soils related to arid climates with low precipitation and high evaporation, give rise to soils that contain variable amounts of easily soluble components such as calcium carbonate and gypsum that is left behind after evaporation of water from the soil. Lastly, we have soils formed in Arctic climates. In Arctic climates, soil formation is even more restricted. Moreover, it is strongly influenced by freezing thawing processes and the presence of permanent frozen subsoil, what we call commonly permafrost. Apart from these types of soils related to climates, We also have other soils. There are various types of soil whose characteristics are not determined by climate. These occur in many regions, and they include mountain soils, saline soils, peat soils, limestone, and alluvial soils. Mountain soils are stony and unstable soils in highlands. They are usually eroded and transported to lower valleys, while saline soils are found in areas where evaporation is dominant. Peat soils are found in waterlogged areas, and they contain dead vegetation which is partially decomposed because of lack of oxygen in them. While limestone soils are common in limestone regions. When they are red, they are called terra rossa. We also have alluvial soils. They are formed from deposited materials such as sand, clay, and silt along the river banks and lake shores. Thank you. Dear students, I want you to use your prior knowledge from previous years and other geographic resources to search on the processes of soil formation. What are the processes of soil formation? All right. Numerous processes are involved in the formation of soil and the creation of the profiles, structures, and other features described by the combined effect of physical, chemical, biological, and other processes working on soil parent material. Soil is said to be formed when organic matter has accumulated and colloids are washed downward, leaving behind deposits of clay, humus, iron oxide, carbonate, and gypsum, producing a distinct layer called the B horizon. These processes are calcification, eluviation, mineralization, humification, weathering, leaching, and lateralization. The first process of calcification is the process in which calcium carbonates accumulate in the B horizon, particularly characteristic of low rainfall areas such as arid and semi-arid climates. While eluviation is the downwards movement of fine particles such as clay and the leach soluble materials from upper layers of the soil, or A horizon, to another lower layer within the soil. We also have eluviation. Eluviation is the process of accumulation of clay, aluminium, and iron, usually from A and E horizons to B horizons. While mineralization is the process through which organic matter is further decomposed into mineral compounds. Mineral content in humus may be further converted into inorganic matter, example silica. We also have humification. Humification is a process by which organic matter is decomposed to form humus, a task performed by soil organisms. While the process of weathering is the process by which the rocks break down into small particles to form soil. It is the combined action of physical weathering, in which rocks are fractured and broken, and chemical weathering, in which rock minerals are transformed to softer or more soluble forms. We also have leaching. Leaching is the removal of soluble material in solution. In this process, water removes leached materials. This means organic and inorganic materials in solution from the upper horizon to the underlying horizon. It operates vertically but not sideways. The last process is lateralization. This is leaching of soils in warm and humid climates. It is a process that occurs after soluble minerals substances have been leached. After leaching, the insoluble minerals compounds derived from the parent rock remain on top, hence forming lateritic soils that are stony. Thank you, friends. Now let's focus on factors of soil formation. Can you think and explain the contributing factors to soil formation? Think and explain the contributing factors to soil formation. Well done. Soil forming factors are both passive, this means parent material, topography and time, and dynamic, meaning climate, living organisms, and man's activities. These factors work together as a system to form soils, to mean passive and dynamic factors. They will work together as a system to form soils. Some of the major factors that influence soil formation are climate, relief, the nature of the parent rock, vegetation, and the activities of animals and bacteria, time, and human factors. Now, we are going to discuss some of them. When you look at climate, the moisture or rainfall, evaporation, and temperature changes determine the chemical reactions and physical breakdown of rocks. This results in soil profile development. Again, relief or topography. Slopes that are too steep cannot have full soil development because gravity and erosional processes remove water and materials. On the other hand, flat areas encourage water percolation or infiltration, which favors the development of deep soil profile, whereas steep relief accelerates water surface runoff, hence a shallow soil profile. We also have the nature of parent rock. In fact, physical and chemical weathering of rocks in the upper lithosphere provides the raw mineral ingredients for soil formation. These rocks supply the parent materials, and the composition, texture, and chemical nature help determine the type of soil that forms. A weathering of fine-grained rock texture tends to form a shallow soil profile, while dark-colored rocks are easily weathered and form deep soil profile. Dear students, clay minerals are the principal weathered byproducts in soil. Another factor is vegetation and the activities of animals and bacteria. Vegetation and the activities of animal and bacteria determine the organic content of soil, along with all that is living in soil. This means fungi, worms, and insects. The chemical composition of the vegetation contributes to the acidity or alkalinity of the soil solution. Also, the care of plants and animals supply the soil in humus and nutrients. Animals contribute to soil development through breaking down of vegetation and rocks into small particles that form the soil. We also have time as factor. All of the identified natural factors in soil development, meaning parent rock, climate, biological activity, and topography, require time to operate. This determines the depth of weathering and the period of operation of soil formation processes. We also have human factors. In fact, human activities have a major impact on soils. For example, the use of fertilizers changes the natural properties of soils. Soil erosion has greatly increased due to agriculture and construction. Are we together, friends? Great! Now, before we conclude our lesson, let us review what we focused on today. Think of one thing you have learned today. Good! Today, we have learned about classification of soils and soil formation over the world. And we focused more on classification of major soil types of the world, distribution of the major types of soils in the world, and we have learned that soils are distributed according to major climatic zones. We also learned about processes and factors of soil formation. Thank you. As a homework, listen carefully. Let's end our lesson by a homework. You will visit your local area and describe the soil formation processes in that area. Then, you will use the acquired knowledge from our lesson to explain how different factors, namely climate, living organisms, parent rock, relief, time, and man influence soil formation. Again, which of the processes learned are the most predominant in your area? Justify your answer. I repeat for you. You will visit your local area and describe the soil formation processes in that area. Then, you will use the acquired knowledge from our lesson to explain how different factors, namely climate, living organisms, parent rock, relief, time, and man influence soil formation. Then, you will tell us which of the processes learned are the most predominant in your area, and you will justify your answer. With that, thank you for your participation. Hope we have met our objectives. I was Teacher Jen. Bye.